So this is the work lab. And basically what you're going to be doing is doing work calculations. And you're going to be trying to figure out how much work you have to do to raise a cart and pulley 1 vertical meter under a circumstance in which the body is moving with a constant velocity, which is to say, no acceleration. You're going to use 3 different approaches to doing this. One's going to be a deadlift, one's going to be up an inclined plane, and one is going to be using a double Atwood machine. Now, as far as data taking goes, there's kind of a little trick that we're going to use. The trick is attached to the following observation. If I am pulling this thing up with 0 acceleration, the amount of force that I'm having to apply will be the exact same force as the amount of force I would have to apply to simply hold it in this position with 0 acceleration. So I don't have to actually physically pull the object up 1 vertical meter, keeping the velocity constant, to be able to find the force that would be required to do that. All I have to do is just hold it in position, hold it steady. And that's what we're going to do. And the same thing on the inclined plane. I could go ahead and apply the force all the way up so that the net vertical displacement was 1 meter, keeping the velocity constant, 0 acceleration. Or I could just hold it in place. And the amount of force that would be required in both those cases would be the same. That's what I'm going to do. Aside from those forces, the only other information that we need are the mass of these 2 objects. And because they're always going to be together, I'm going to give you those masses together. So the mass of these 2 together is 539.2 grams, or 0.539 kilograms. I'm going to take the cart and the pulley together and attach it to the force transducer. I've got to 0 this thing in this position. So when it's in the vertical like this, it's 0'd. I'm going to go ahead and put this on like so. So it's basically doing a deadlift, and the amount of force is 5.28 newtons. Okay. Now I'm going to go ahead and use this incline. Okay, I'm still using the cart and the pulley together. I'm going to put the cart and the pulley on the incline. I'm going to put the force transducer in the appropriate position, and I'm going to 0 it in that position. So it's registering 0. And now I'm going to go ahead and see how much force is required to hold it. And apparently it's 0.73 newtons. And the angle of the incline I'm zeroing this. The angle is 7.0 degrees. So the angle of the incline is 7.0 degrees. Okay, so here you have the pulley and the cart. It's a double Atwood setup. You can't very well see it terribly well, but that's the setup that you're looking at. I have the force transducer attached so that the force is on axis, and the amount of force according to the computer is 2.60 newtons. That's all the data you get.